Hello everyone. In this video and also in some next videos, we will learn how to draw the molecular orbital diagrams of some simple molecules. So let's start with the simplest molecule, and that is H2. Here two hydrogen atoms are there, so it can be said as one of the example of homonuclear diatomic molecule. So if we take one hydrogen, its electronic configuration is 1s1. Okay, so two 1s orbitals of two hydrogens will be involved to give the H2 molecule and also two molecular orbitals. So first let's draw the energy axis. It is the energy axis, and two hydrogen atoms are there. It is the 1s orbital of one hydrogen and another 1s orbital of another hydrogen. So if you assign the two hydrogen as HA, HB, then let's this one the atomic orbital of HA and this one as atomic orbital of HB. Okay, now these two 1s orbitals will combine to give the two molecular orbitals of H2 molecule. Why? Because if you read the salient features of molecular orbital theory, then you will know that the number of atomic orbitals involved in the combination will give the same number of molecular orbital as well. So here two 1s orbitals are there, so it will give two molecular orbitals, one of which will be in lower energy and the another one will be in the higher energy. Okay, this one actually the in phase overlap and it is the out of phase overlap. So this will give the bonding orbital and it will be assigned as sigma 1s, and this one will be the sigma star 1s. Star means the anti-bonding orbital. So it is the bonding molecular orbital and it is the anti-bonding molecular orbital. Okay, next is to fill up with the electron. Here you see only one electron is there in the 1s orbital for hydrogen. So two hydrogen atom will have two electrons in their 1s orbital. So here will be in the bonding molecular orbital, that is the sigma 1s orbital, there will be two electrons, because the lower energy orbital, molecular orbital, will be populated first and that can accommodate two electrons. So it will have, that is the sigma 1s orbital will have the two electrons, and the sigma star 1s, that is the anti-bonding orbital, will be vacant. Okay, so this is the molecular orbital diagram for H2. So you will write here the MOs of H2. This is the atomic orbital of HA, HB, and these these two are the molecular orbitals of H2. Now we will write the electronic configuration. Electronic configuration of the H2 molecule in molecular orbital diagram. So electronic configuration will be sigma 1s2. Okay, because here two electrons are there. Now we will calculate the bond order. Bond order calculation, you have to count the number of electrons in the bonding molecular orbitals and in the anti-bonding molecular orbital. Here the anti-bonding orbital, molecular orbital, is vacant, so only the two electrons are there in the bonding molecular orbital. The formula is the number of total electrons in the bonding molecular orbital minus the number of electrons in the anti-bonding molecular orbitals divided by 2. So it is written as NB means number of electrons in the bonding molecular orbitals, and the number of electrons in the anti-bonding molecular orbital. BMO, you can write ABMO, anti-bonding molecular orbital, divided by 2. So here we are getting number of bonding molecular orbitals, electrons are 2, so it will be 2 minus 0 divided by 2. Okay, so it is giving 1. So the what we are getting, that between the two hydrogen molecule atoms there is only one bond, that is the sigma bond. We already know that, but with the help of molecular orbital diagram we can explain why there is only one bond between the two hydrogen atoms in the H2 molecule. Now the magnetic properties. Magnetic properties, I hope you know that if there are unpaired electron, if there is any unpaired electron in the molecule, that molecule is called paramagnetic molecule, and if there is no unpaired electron, that is called the diamagnetic molecule. Here you see only 2 electrons are there, and that is paired up in the bonding molecular orbital. So no unpaired electron is there in the molecular orbital diagram, so it will be diamagnetic. So magnetic properties will be diamagnetic for H2 molecule. Okay, so that's all for this H2 molecule. So now for He2 we can use this diagram as well. So just we have to change a little bit. So helium He2 means helium has the electronic configuration 1s2. Okay, now it will be 1s2 and it will be helium A and it will be helium B. Okay, so this one will also be, there will be 2 electrons because electronic configuration is 1s2 and it will be He2. Okay, now if we see the electrons here, 2 and 2 means 4 electrons are there, but in the bonding molecular orbitals there are 2 electrons, so the antibonding orbital will also have 2 electrons because there are 4 electrons coming from the 2 1s orbital of the 2 He atoms. Okay, so if we write the electronic configuration for He2, what will be the electronic configuration? It will be sigma 1s2 and sigma star 1s2. Okay, now the bond order. Bond order will be, as I wrote in the earlier for H2, the number of electrons in the bonding molecular orbital minus number of electrons in the anti-bonding molecular orbital. So here in the bonding molecular orbital there are 2 electrons, in the anti-bonding molecular orbital also there are 2 electrons, so it will be 2 minus 2 by 2, so it will be 0. That indicates that He2 molecule does not exist. So bond order 0 means what? Here 2 He, so there will be no bond, so each of the helium atom will exist as mononuclear atom, and the magnetism does not arise because He2 molecule does not exist. Okay, so in this video only the 2 simplest cases we have discussed for homonuclear diatomic molecule. In the next video I will discuss some other examples like from lithium Li2 to Ne2, and then we will go into the heteronuclear diatomic molecules and also some polyatomic molecules. Okay, that's all for this video. If you are new to my channel, kindly subscribe my channel to get this type of videos more. Thank you all for watching my videos.